Hi guys, if you haven't watched the companion video to this, then I urge you to take a look at I think it's over there, should be over there somewhere. Take a look at the first video for this. This introduces the C++ server. So what we're going to do today is we're going to take that code and then we're going to build a class from it so that we can eventually have basically a sort of a software stack of components. So what I'm thinking is, down the bottom here, we're going to have our network layer. And our network layer is going to have a sort of glue code, for lack of a better word. And that's going to link it to our what's typically called business logic. And our business logic is basically our program. So that's the rules that make up the game. So if you've got, if you're playing a card game, then you'd have the rules for the card game. If you're playing, Rocket League, that kind of thing, you'd have the rules for the physics and all that kind of stuff. All of that is contained inside your business logic. And then we have a link between the glue code and the network layer. And this glue code, this bit in the middle, links the network layer to our business logic. But what we're interested in today is this layer here. So we are going to build, and my pen's running out, we're going to build a C++ client, which we're going to call Tcp Listener. Because that's what it's going to do. It's going to listen for a connection, and when it gets a connection, it's going to do something. So we're going to build upon this over the next few weeks anyway. So our TCP listener is going to change. Right now it's just going to be a copy almost of the code that we did from last time, but in a class. And then the next video from this, I'm going to do a quote server, and we'll connect to it using PuTTY. And in the videos after that, we'll then bring in Unity. And we'll have a quote of the day client that will connect to the server, get a quote of the day. And so we're kind of building on this as we're going along. So anyway, that's it as far as explanation is concerned. So let's get down to it straight away, and we start coding after the fade. So we start with doing file new project, and we're going to make this a C++ server. So we're going to make it an empty project, and I'm going to call this our listener thing project. I'm going to call it listener project, and then that's going to fire up, and the template will start, and we'll eventually get in here. Okay, so you might have it on the other side here, but it doesn't really matter. I'm going to add a new item, which is going to be our main class. Our main entry point, I should say, and that's going to have include IO stream, include string, using space std. Of course, that's bad, terrible, whatever, but we're going to use it for that just now. We're going to have void main, and that's all we need for our main program. Now our header file, we are going to create a new item here, and it's going to be TCP Listener. So I'm going to create a new class called TCP Listener. TCP. And our listener class is going to have all the same things that we had for our bare bones server. Now, normally if I was doing this myself, I'd copy the bare bones across and all this kind of stuff. But I think it's better if we just do this straight off the bat. So if you want to, you can copy the code over from the bare bones server. Some of it might be slightly different, so you might have to change a few things, but for the most part, it's going to be similar to this. So we're going to have to create our callback. So this is our function pointer. So again, if you're missing any of these terms, there's videos over on the left hand side there-ish. So as you're viewing it, it's the right-hand side, but from my point of view, it's the left-hand side, that talk about function pointers. So callback to data received. So I'm going to do some callback to data received here. And then we're just going to fill in all the things that we need to do. So we need to initialize WinSock, create a socket, wait for a connection, receive loop, send back message, and then clean up. So these are all the kind of things that we need to do for our class. So because this is going to use WinSock, we're going to have to do include ws2 TCP, and then we do our pragma comment lib ws2 underscore 32.lib. So this is our header file for. This is the header file for all our WinSock functions, and this is the basically the executable code, the library file, WinSock library file. So that actually contains all the executable code. This contains all the function prototypes that we need. All right. So our listener. And again, there's a couple of ways we can do this. Let's do it so that we have to pass in the values into the constructor. So if we do Tcp Listener, and we need to take in a string, which is the IP address, the port, and we need some kind of data received function. So I'm going to say message received handler, for lack of a better thing there. So I'm going to have to include a string because I need access to string. And I don't have this message received handler, so I'm going to have to create my callback here. So I'm going to do type def void, and this is going to be our function pointer is going to take in Tcp listener, int socket ID, and then I want to take in the message received. And I think I just want this as a string. So it's going to complain that this class doesn't exist. And the reason why this class doesn't exist is because it's down here. Oh, sorry. I need a pointer to it. And the way I can get around that is I can do class C TCP listener and just forward declare it. It's going to call me a liar. I'm pretty sure it's going to call me a liar, but if I compile the code just now, that's fine. But if I compile it now, yeah, it's going to call me a liar. Whatever. It's best to forward declare these things. Okay. So we now have our message handler, which means that we now have some private member fields. So our IP address, this is our port, and then we have message received handler. Oh, I need one more there. We'll call that message received. Okay. We also need a way to send a string as well, because if we go back to this diagram here, our network layer is completely separate from our program. So our network layer is only there to receive messages and pass them on to the program, and it's up to the program to then send that message back. So we're going to have to send, so that's going to be void send, we'll just call it send, capital there, and it takes in a string message, and we'll also pass in the client as well. So I'm going to say int client socket. And the reason why is because maybe we want to send things back to a specific client, or maybe we just want to broadcast them. So just for future reasons, I want to make that, that's the signature for this function here. And you'll see there's a squiggle there because we don't actually have it implemented. Okay, so initialize winsock, bool init. So that's easily enough done. Send a message to the specified client. Create a socket. So create a socket and wait for a connection. These are internal. We don't want them to be exposed. So I'm going to say socket, create socket, and then wait for a connection is also going to have wait for connection. I'm also going to respond and give that a socket as well, because that's going to return back the client socket. Yeah, I think I'm okay there. I think that's all I need to do. And then we have our loop as well. So we do void run. So this is our main loop, the main processing loop. Okay. Oh, we need to clean up as well. So we need to do void cleanup. And we should probably do that inside the constructor, destructor as well. See TCP listener. Okay, so what do we have now? Okay, so we're including string because we need to have access to string functions. We're including this because we want access to the winsock library. I'm doing my forward declare there so that I can have access to this variable here because we haven't declared it. So this is our forward declaration. And this is the message received handler, the function pointer that we're going to pass in. And it's going to have the same signature as this, and it passes back the instance of the class, the client socket, and the message that was received. Okay. And I think we're good to go there. So on the main program side, all we have to do is, let's say we do we need to include TCP list. Oh, sorry. It's local TCP listener. So then we do TCP listener. Server, and that takes in some things. It takes in the IP address. The port number, which I'm going to make 54010, and the reason I'm doing that is because Avast annoyingly makes me want to do that there, and the message received handler, so that's going to be listener message received, which of course doesn't exist, so now I need to do void message received, which is going to be TCP listener. If you're wondering what I'm doing with this, have a look back at the function pointer video, but I'm basically making the function pointer for this. Listener int client bring message. And now I have to make this instance here. So there is my definition of our function, which does nothing just yet. It also takes in a pointer as well, rather than that. And why is this complaining about this? is inaccessible. Well, that's why, because I didn't do this. Okay, so now I'm going to go back to main. Everything's fine. All right, so our server's there, and now we say if server.init server.run. And that's it. That's as far as our main program is concerned. So remember that our main program had all that networking code in there. And even now, the only networking-ish code we have is we have a reference to our own TCP Listener class. And why this is super important is because now we've extracted the actual handling of networking to this layer, this TCP Listener class. So any messages we get received, we can then manipulate inside here, and we don't need to do a specialized version of our TCP Listener class. So now it's just a matter of filling in the methods in the TCP Listener class, and then we can take this for a little bit of a spin. So that's what I'm going to do just now. So I'm going to copy all of these, and I am going to create a new CPP file, which is going to be called TCP Listener, and I'm going to include TCP Listener, and I also need these as well. Create a socket, and every single one of these has got to be down here. I'm just adding these braces just now. Okay, and then I want to have this in front of everything because I need to say that these are members of this class. Whoops. So that we can have access to the variables and we can have access to the other methods as well inside here, because we need to have access to create socket and so forth. Okay. All right. So our TCP Listener constructor is really just going to contain IP address, import is port, and message received is handler. So we're just initializing these values, and then our destructor we're just going to call cleanup. And the reason why I want to call cleanup is because I want to, if someone doesn't explicitly call this, then I want to be able to clean it up. Our send function, we are going to be using send, basically. So our send is just going to be send, and then it needs the socket, which is our client socket. And we need a buffer, which is our message.cstring, cstring. And then we want the length, which is message.size +1, and then 0. And again, I'm getting all this from the previous videos that we did on networking, which are linked up there. And that's our send done. So we've done send, we've done our constructor, we've done our destructor, and now we have our initialization here. So our initialization, we need to pass in the version number of WinSocket we want, and also the structure that gets filled in. So I'm going to do WSA data word var equals make word, and we're going to have two because it's going to be version 2 of WinSocket that we're using, but I can't remember which way around it is, so it just gets the version that's closest to it, so it works out. Okay, int ws init equals wsa startup. So we have to start up, and again, if you're doing this on a Mac, you won't, or a Mac in Linux and Unix, you won't have to do this. This is the WSA startup, WSA cleanup, are actually part of Windows, so you're not going to have to call these. So the version request is var, and then we pass in data. So if ws init is not equal to 0, I think we probably do want to pass out an error, but let's just do return ws init equals 0. So maybe we'll do to do inform caller the error that occurred. So there might be an error that happened and we might want to tell someone about it. Okay, so cleanup. Because we're going to do the majority of stuff inside the run loop, the only thing to do in cleanup is WSA cleanup. That's it. So we don't really need to do anything else. So we just need to call that. For our create socket, we need to do some work here. And similarly, we need to do the same thing for wait for connection. Now, I'm just going to do the naive version of it. We're not going to pass in any variables or anything. We're not going to figure out who connected to whom or whatever. We can add that later on if we ever need it. For logging purposes, I'm just going to do a very, very quick version of it. So our socket is going to be socket. This is going to be the listening socket equals socket if inet, because it's the IP version 4. Type is stream, because we want to have TCP protocol. And we specify 0 because the protocol gets filled in. So we say if listening is not equal to invalid socket, then we want to say int listen okay equals, actually, sorry, we want to bind to a socket. So we want to do socket address, and again we're using Internet Protocol 4, so this is our hint. So hint.address family is AF inet. Hint.port is htons import, because we're getting this from up in our constructor. So our constructor is up here, and so port gets assigned, import gets assigned the value inside port. And then we need to specify the name of the address. Then we're going to just kind of pass in the IP address. So we're just going to worry about inet piton just now. So we'll do, or we're not going to worry about inet piton, we're going to use inet piton. Inet piton, which converts our string, which is 127.0.0.1, to a byte representation of that. So we need to tell it what format that address is in. So that's AF inet. Specify the address of the string, which is mipaddress.c string, because it's a C++ style string. We need to get into C string. And then we specify the address buffer, which is going to be hint.synaddress. And then we want to bind this to the socket, so that the socket is now connected to that IP address and port tuple, so that when we refer to that socket, we're actually referring to the port number and the IP address that it's been bound to. And then we want to listen in on it. So if int bind okay equals bind, and then we specify the socket, so this is listening. The pointer to that hint structure, which is hint, and then the length of it, so size of hint. So if bind okay is not equal to socket error. Sorry. Then we want to listen in on it then. So listen, okay, equals listen. And then we want to specify the socket, so listening. And then the backlog, which is so max colon, which is good enough. And then if listen okay, well actually if listen okay equals socket error, return -1. And then we want to do the same thing for here as well. So we want to be able to give like a -1 if something fails. So let's read through this though. Create socket, we create our listening socket. We also want to return listening. Okay, let's read through that again. So we create our listening socket here, we check to see if it's invalid. If it's not invalid, we create our hint structure that we're then going to use to bind that IP address and port number to our socket. So the two are going to be linked. So we try and bind them. If we don't get an error from that, then we try and listen in on that socket, and if it fails, we return -1, either for the bind or for the listen. Otherwise, we return the socket. So if it fails at this point, listening is going to contain -1, and if it fails at this point, it's going to return -1, and if it fails at this point, it's going to return -1, and then eventually it's just going to return whatever the value is that we create in there. So that's our create socket. Our wait for connection is going to be socket client equals accept, and then it's going to be our listening socket, which means we need to pass in our listening socket. So we need to pass in listening socket. So we're going to have to change our header up here. So I'm going to do socket listening. And then we want to accept on our listening socket. And I'm not interested in this. I'm not interested in this. So I'm not interested in finding anything about the client. I just want to see if it connects. And then I just want to do return client. And that's it. Wait for a connection. So this will wait for a connection, and then it will return the client. Okay. I think we're good so far. Any questions? If you have, make sure you put comments in the notes down there if I'm going too fast. I do encourage you to go back and have a look at the barebones server that are linked up there, that I keep pointing up in that direction there. If you're not following this bit, but essentially it's the same code that we had in the barebones server. The only difference is that we're making it a class, which means we can do other things with it. Okay, so initialize there. So we do run here. So our run here, I'm going to have it as just a while loop. For now, I think it's good enough that we just have it as a while loop. So while true, we'll just continue doing this. So inside our while loop, we want to create a listening socket. Wait for a connection. Loop. Receive. That's not how you spell receive. Send. Okay, so we want to have a loop send there. So our listening socket is going to be listening equals create socket. If listening equals invalid socket, break. Let's leave, if we can't get a valid socket, let's just leave the loop. Otherwise, what I want to do is I want to try and get a client socket. So socket client equals wait for connection. And we have to specify our listening socket here, which is listening. So there's our listening socket there. So there's our client. we're getting that there. If our client is an invalid socket, actually if our client is not an invalid socket, so if we have a valid socket at this point, what we want to do is we want to get into a loop. So we want to close our listening socket, and then, so we want to get into our loop here. So we're going to do while, actually int bytes received do, and then that's while bytes received is greater than 0. So how do we know how many bytes we've received? We received a number of bytes. So we do receive, and it requires a socket and a buffer. So we need to create a buffer as well. So our buffer will create up here, where we will have, let's define a size for the buffer. So let's also do define max buffer size, and we'll call it 49152. It doesn't matter whichever value you want, but I'm going to choose max buffer size 49152. So it's 48K ish. So I want to create a character buffer of that size in there, and then when I receive something, I want to 0 memory my buffer by that size. So I want to clear out that memory, and I want to receive into that buffer. So I need to specify the socket, which is going to be my client socket because my client is connected, and then I want to receive into that buffer. The length of the buffer is that, and the flags is 0. So if bytes received is greater than 0, I want to send that to the main program. And the way I send that to the main program is through here, my message received. But I need to check to make sure it's not null. So if message received is not null, message received, and then I need to specify this, the client socket, and then the actual message. And the way I'm going to construct the message is it's asking for a string. So I'm going to pass in string, and then I'm going to specify the buffer, the starting index of the number of characters to copy into the string, and also the size of it. So I'm going to say bytes received. And it's telling me that I've got a mistake there, which means I don't have that. And that's it. So at this point here, I want to close the client socket. Because I'm now out of the loop, I'm no longer receiving things. So basically the client is disconnected, and I want to end that. So our main loop is going to create a socket, a listening socket, wait for a connection. When a client connects, it's going to close the listening socket so no one else can connect. It's then, while the client is connected, it's going to receive data, and then it's going to send it to this main class, which we'll deal with in just a sec. And then if the client disconnects, it closes the client socket, and then comes back up here, creates another socket. So we should be able to keep connecting to the server every time we disconnect from it. Okay. I think we're good there. Okay. So in our main program here, we have this server. There's not much to it. Basically, we're creating a listening thing, and we initialize it and we run it, and then that's it. And then something happens that when the client receives, when the server receives a message, it ends up in here. So we're just going to echo it right back again. So we're going to do listener, send, and then we want to send it back to that client. So we're going to specify client, and then we're going to specify the message. And that's it. So this is basically going to be our echo server again. So all that code that we had inside our main program for the bare bones server is now going to be in here. So when we want to make a program that uses networking that has some kind of server component, all we need to do is we need to create this server, we initialize it, we run it, and then anytime we receive a message, we perform some kind of operation, which in the next video that follows on from this will be a quote server. So we'll send back other additional data. But this is the only code that we need now to do our echo server. So I'm going to compile it and make sure I've not made any mistakes. Okay, well that worked. Worryingly, it's always worrying when things just work. So I'm gonna run this now, and we'll see what we get. And obviously, Avast is going to pop up and tell me it's doing something bad. This file may contain something bad, like my code. Oh yeah. Okay, so it should pop up again. All right, here we go. So it's running in the background, so I'm going to bring up PuTTY, and I'm going to double click on this one here. So I'm not getting any connection things up here on the server. That's because we don't have anything. It's very, very bare bones. As far as that's concerned, we don't have any information. But if I type in hello, I should get back hello. And that's what we do. World, this is awesome. And it returns back. So when I close this, the server shouldn't terminate, but I should be able to connect to it again and still talk. Still listening. There you go. Okay. So now we have a server that's fairly robust and handles client connections and client disconnections. And the beauty of it all is that everything is hidden behind a couple of methods. So our header file here, we have, we never even call cleanup, but whatever. We can get rid of that. Clean up after using the service. And we'll look about how to shut that down as well. Maybe not in the next video, but the one after that. So yeah, this is our 4 methods that we have. We basically, all we need to do is call initialize. It initializes WinSock. We run the server and it does all the main loop for us. And all we have to do is send data back to the client. And we can rig this up as well, that we can actually have a broadcast. We're gonna look at a function called select that's going to allow us to do multiple connected connected clients. And that's our couple of private methods down there. And then that's our fields that we need for our the operation of the server. And this is our program here. And our program, all it does, creates an instance of our TCP Listener class, calls the initialize, calls run, and then receives the message. So now if I set a breakpoint here, and I run the server, and I connect using PuTTY, and then say hello world. My breakpoint hits. I'm inside my main.cpp file, and you can see that it's called from, if I look at the call stack, then you see that, sorry, I'll bring call stack up a bit so you can see it. So you can see that the TCP listener run called our message received, and now we're inside message received, and message does indeed contain hello world, and we have our client there. And I'll press F11. It takes me through here. Where are we? I pressed F11 too much. Oops. I think I'm in string. Yeah. Oops. Okay, anyway, let me just quickly go back through that and then just go to here, which is our send function, and I'll press F5 rather than going through all the strings. And you see that we've got the 248 and we have our message of hello world, and then we send that back out again, and it will appear on putty. And that's that. Well, I hope you enjoyed that video. That's the I don't know how many networking videos we've done so far, but that's just another one there for you. So yeah, splitting off the network layer rather than having it as part of your main program is a great way to go. So yeah, so next time we're going to be looking at doing a quote server, and the quote server is not going to change any of the code on the TCP listener side. We're only going to change the main program. So yeah, hope to catch you next time. Thank you very much for watching, as always. And thumbs up, thumbs down if you didn't like, whatever it is. There's some info cards up here-ish for other videos that you might be interested in. And please subscribe. Please subscribe. It's a new thing that YouTubers have to say now, apparently, is please subscribe, because whatever. Or don't subscribe. I hope you enjoy the videos. That's the main thing. Anyway, I'll catch you next time. Thank you very much for watching. Bye-bye.